first example there, that's a compound inequality. Have you ever solved those? Where you've got -6 is less than or equal to this expression, which is less than -3. Raise your hand if you think you've solved those before. Okay, so you haven't. All right, you're going to find it easy, but I just want to see what I'm working with. So the idea in general is still going to be to get x all by itself, but rather than having two sides to the inequality, you really have three. So we're going to look at this middle expression. We're going to isolate the x just like we have always by adding 4, but rather than just having one other side to add 4 to, we have to add 4 over here to the right and to the left. So that's going to give us -2 less than or equal to 1/2 x less than 1. And then to get rid of the 1/2, what do you do to get rid of that, Alyssa? Multiply by 2. And again, we're going to multiply by 2 on the left and on the right. So we have -4 is less than or equal to x, which is less than 2. Now, typically with inequalities, I would say always with inequalities, there are an infinite number of solutions, okay? Not necessarily an infinite number of integers, but an infinite number of solutions. This notation essentially means that any x value that's between -4 and 2 is a solution. So that's inclusive of -4 because of the less than or equal to. That's not inclusive of 2 because of the less than. But you present these visually on a number line. So anything between -4 and +2, -4 gets a filled in circle because of that or equal to, and 2 gets an open circle, and then we would shade in between. So that's a visual representation of the infinite number of possibilities. Any questions on that? Have you graphed things like that? All right, so does that look familiar? Once it's already, like, it's written as a compound equality, but you just didn't ever solve them, I guess? Okay. All right, so that's not a bad jump from where you were then. Number 2 is an absolute value inequality. Now, this is a little bit trickier. I'm going to kind of play that game where I'm covering this up with my fingers. What numbers would make this true? What number could be underneath my fingers to make this true? 20. What else? 19, 18.
-20.
All the way down to, what's the smallest number? -20. Once I get to -21, that would not be good, right? Because the absolute value of -21 is 21. 21 is not less than or equal to. So this that was just underneath my fingers needs to be between -20 and 20. Yes? By that logic. So we can sort of set up one of these over here. So that expression has to be between -20 and 20. And then I'm going to solve, so I'm going to subtract my 2. So -22. Can I distribute at the same time? I'm going to do that. I'm going to distribute the 3 at the same time. Then I'm going to add the 3. And then I'm going to divide by 3. So that's going to be -19 thirds is less than or equal to x is less than or equal to 7.
What was
You could, yeah. Yeah. Yeah, you should get the same answer. Any questions on that? Okay, on the next one, now number 2, the way it started, the absolute value is already isolated, right? We don't really kind of break free from the absolute value until it's isolated. So in number 3, we need to isolate this absolute value by subtracting the 7/3. What is 1 minus 7/3? Negative 4/3. Share with everybody how you did that so quickly, Taylor. Right, so she quickly got that common denominator. Negative 4/3 is less than the absolute value of x minus 11/3. Now I'm going to think logically about this. What could be underneath my finger? What kinds of numbers? So that negative 4/3 will be less than the absolute value. Raise your hand if you have a feel for what's going on here. Can anybody think of any number at all that would make this, what that could be underneath my finger? Jalen? It can't equal a negative, but this isn't saying that it equals a negative. It's saying that this negative number is less than the absolute value of what? Zero and up. So if what's underneath my finger was like a 2, that would be true, right? Does everyone agree with that? Negative 4/3 is less than the absolute value of 2. But why did you exclude 0 and down? Because even if what's underneath my finger is negative 5, what's the absolute value of negative 5? 5 is negative 4/3 less than 5. Right. So this side, because it's got absolute values around it, is always positive, yes? Isn't a negative number always going to be less than a positive number? So no matter what that expression ends up being, this is always going to be true. Yes? So this is, x can be any element of the real number system. Anything is a solution. Okay? You're going to see problems like this, sort of kind of like a system, and they give us that y equals 2x minus 11 plus 3 times x plus 2, and then they tell us that y is at most 0. I'm trying to remember what the instructions are. To solve for what? Because we have 2 variables. Give me a moment. So we are trying to find all values of x that would satisfy this. Yes? So let's start with this. Let's translate this out of the inequality language and into math. What would we write in math that says y is at most 0? Lily J. Very good. So this is the same thing as y is less than or equal to 0. Now, it's sort of like a system, but one's an equation, one is an inequality. But we want to solve for x, so we're going to try to get our y's out of there. And we can do that pretty easily because y is equivalent to this expression. So this expression can replace this y down here. Yes? So we have 2x minus 11 plus 3 times x plus 2 that has to really be less than or equal to 0. I distribute my 3, and then from here it's hopefully pretty straightforward. I get 5x minus 5. 5x is less than or equal to 5. And then divide both sides by 5, and I get x is less than or equal to 1. The instructions actually on your homework are going to say use interval notation to express this. So who can tell me what this is going to be in interval notation? Do you remember interval notation? Brackets, parentheses, like this, like 5 to 7, kind of like that. So what would this be in interval notation? Stephen? Yeah. Bracket. Yeah, parenthesis versus bracket. So from negative infinity up until 1, that's your interval notation answer. And so at the bottom here, we're going to talk about those notations, how to get from interval notation to set builder, and then vice versa. So this is including negative 4, right? Up until 2, but not including 2. So this is the set of all x's such that, and if you're falling between two numbers, you're going to use that compound inequality. So from negative 4, which is less than or equal to x, which is less than 2. We're always going to go smallest to biggest there, so we're going to say the smallest is less than or equal to the variable, which is less than or equal to the higher end of your restriction. And because of that, if we always go smallest to biggest, we should always be using less than or equal to signs. You would never use a greater than sign if you're ordering something smallest to biggest. Okay? This one, x has to be really between negative 19/3 and 7, and it's inclusive of both, so we're going to use a double bracket, negative 19/3, comma 7, and they both have brackets. What would, if your solution set is negative infinity to positive infinity in interval notation, what's that going to look like in set builder notation? Or what's your interpretation of that? What are the solutions? Is that Josh's voice I heard? What'd you say? All real numbers. So in set builder notation, we would say the set of all x's such that x is an element of the real number system. We kind of already approached this issue in number 4 when Stephen told us the interval notation up here. So if you're less than or equal to 3, that means you're going from negative infinity. Infinities in general always have parentheses. You would never use a bracket around an infinity. Up until 3 with a bracket here because we're including 3. The less than or equal to section of that sign tells us that we are including 3. Jack, is this familiar, the interval notation? Okay. Yeah, but didn't use it often. And then this one, if your solution set, and I'll just sketch this one visually, your solution set is from negative 5, inclusive of negative 5, all the way to infinity. So as far as an inequality, how would you write an inequality for that? Connor?
Negative 5 is less than or equal to x, which is less than or equal to.
You don't, because it's kind of increasing without bound, you don't need the complex, the compound. You can just say the set of all x's such that negative 5 is less than or equal to x. Would anybody else have done something different? Steven? You would have said what? Right, that's, okay, that's what I thought you were saying. Right. I knew what you meant, but when you just say I flipped it, the rest of your classmates may not know what it is. So either one of those would have been fine. I, too, usually put the X on the left-hand side, but... All right, and here's a union. So I'm going to visually present this, too. The first set of solutions is from negative infinity up until 3. So I'll just throw a 3 on a number line. That 3 has a parenthesis around it. So that's going to be an open circle. So we're not including 3, but anything up to 3. And the negative infinity up until that will be this set of solutions. And we have a union symbol. We're uniting that with 7 up to infinity. And we do include the 7, right? You see the brackets on the 7? So I'm going to fill that in. Okay? So in set builder notation, this is a little bit different because we're not filling between two numbers. So when we turn this into an inequality, we're not going to have this notation here where x is between two numbers because our solutions are not between the 3 and the 7. They're on the outsides. And unfortunately, there's not really an efficient way to write this other than to write two different inequalities. So we would say the set of all x's such that x is less than 3, or, use the word or, x is greater than or equal to 7. You actually have to use the word or there. Versus here, this really means that x has to be greater than or equal to this number and x has to be less than or equal to 7, but we don't use the word and because we can write it more efficiently in that compound inequality. Is that clear? Okay. And then lastly, we have a little more practice with unions and intersections, but in this interval notation. And I have number lines there to kind of help us with this. So we're looking for the intersection between the set of numbers from negative 4 to 0. So here's negative 4. Here will be 0. Both open circles because of the parentheses. So that's the first set. The second set is going to range from negative 2 to 1, and that's going to be closed endpoints. Now if they're asking for the intersection, then we're essentially looking for where those two overlap. And we're going to present our answer in interval notation. So they are overlapping from what number to what number? Let's go with Kendall. Negative 2 to 0, and then tell me about the signs that I'm going to use. Am I going to use a parenthesis or bracket on the negative 2? Bracket, good. Parenthesis or bracket on the 0? Is the 0 in both sets? No, because that's an open circle. So it's got to be an open circle or a parenthesis there. Good? So your set of overlapping starts at negative 2 and goes up to 0. 0 has an open circle, negative 2 has a closed. That makes sense? Okay. On the next one, we have negative infinity up until 6. 6 has an open circle. And then we have 2 to 9. But here they're not asking for the intersection. So we're not really interested in where they overlap. We're interested in collectively grabbing all of those numbers and writing the interval notation that includes all of what we just grabbed. Raise your hand if you think you can take a stab at that. Winter? What's that? No, not where they overlap. Intersection symbol means overlap. Union symbol means we're trying to come up with the interval notation that's going to include all of those numbers that just got shaded in. So you're kind of uniting them into one larger set. Jack, I'll let you take a stab at it. Negative infinity to 2, and then again from 6 to 9. Why did you leave these out, though? Right? Negative infinity to 9, good. You don't want to leave anything out. Negative infinity to 9. What sort of symbol around the negative infinity? Parenthesis, because that's always. And then what kind of symbol around the 9? Bracket. Good. Are they done? All right, and take a minute, try the last one on your own. Nathan Z, what do you think? Say that one more time. Why negative 2? Just 2 to infinity. Okay, so here's the graph. Oops, I refroze it. Here's the two individual graphs. When you're uniting them, almost kind of imagine them merging into one picture, right? And you'll have everything filled in from 2 to infinity. Does that include the 2 or not? Yes. Bracket, always a parenthesis. Okay? We're not done yet. There's a couple things as we were going over this that I wanted to, actually on the front side. I want to do number 2, the exact same problem, but I'm going to switch it to greater than or equal to 20. Okay? So I've got the absolute value of 3 times 2x minus 1. Oh, it's not 2x minus 1, it's just x minus 1. Plus 2 is greater than or equal to 20. So I'm going to cover this up now, and I want you to think about what kinds of numbers will you take the absolute value of, and it will be greater than or equal to 20. Stephen. 7? Think about 7. If I took the absolute value of 7, would that be greater than or equal to 20? No. So not all real numbers. Liam? Any number that's higher than 20, for sure. 20 would work too, right? Because we got the or equal to 20, 21, 22, 23, 24. So thinking about a number line, all of those numbers would work. What else, though? Liz. Yeah, negative 20 and down. Because if I have negative 21, the absolute value of that's going to turn it into 21, and then that would be good. So that would be negative 20 and down. Now see, when you are looking for solutions that kind of on a number line go the opposite direction of each other, you can't do this compound inequality thing again. You actually have to write two separate inequalities. So on the one hand, I would take this, kind of like you do with absolute value equations. You write two separate equations. We have to write two separate inequalities. The first is that that number can be greater than or equal to 20. The second is that that expression can also be less than or equal to negative 20. So I just gave you the logical approach. To summarize it, if you're a fan of rules in general, you keep one inequality exactly the same way as it is, just drop the absolute values. And in the other one, you drop the absolute values, keep everything the same on the left, but you switch the direction of the inequality and you change the negativity. Okay? So it goes from positive 20 to a negative 20. Does that make sense? Okay? So I would solve each of these separately. 3x minus 3 plus 2 greater than or equal to 20 gives me 3x minus 1 greater than or equal to 20. Gives me 3x greater than or equal to 21. And x is greater than or equal to 7. Or this. Same thing on the other side. Just when you add 1 to both sides now, it's going to kind of bring you in the other direction. 3x has to be less than or equal to negative 19. And then I divide 3 on both sides, and x has to be less than or equal to negative 19 thirds. Okay? This kind of breaking it up into two separate technique could have been used on the front side as well. Okay, so for this particular one, I'm going to graph these solutions. Greater than or equal to 7 would put you that way. Less than or equal to negative 19 thirds would put you that way. So that would have been that solution. If I had had the less than or equal to 20 as my starting, I could still break it up into two separate ones, even though we didn't on the front side. I could say that 3 times x minus 1 plus 2 is less than or equal to 20, so it would have been kept the same. And on the second one, I could have switched the direction of the inequality and the symbol, and this would have provided me with really the same two answers, but just different signs. So x is less than or equal to 7, and this is what we got on the front side. These are the answers we got, except for ours was presented as a compound inequality. So look at the difference with how these solutions are graphed. If x has to be less than or equal to 7, we're going that direction. Greater than or equal to negative 19 thirds, we're going that direction. Do you see how this one plots between the two numbers? That's why that one could have, and we did originally write it as a compound inequality using this order. So if you want to kind of just split it up, split any absolute value up into two separate inequalities, just to do the same thing kind of every time, you may do that. Homework is there at the bottom. Goodbye.